Hello students, today we are going to see some more interesting and important questions from basic redox reaction, that is from Narendra Avasthi sir's physical chemistry. Come on, let us discuss the first question. 2 moles of N2H4 loses 16 moles of electron is being converted to a new compound X. Assuming that all of the nitrogen appears in the new compound, what is the oxidation state of nitrogen in X? That means here they have given very clearly 2 moles of N2H4. So here 2 moles of N2H4 loses 16 moles of electron when it is converted to a new compound. So here 2 moles of N2H4, it's converted to X, a new compound. In that, how many electrons it loses? It loses 16 electrons it loses, right? So that means we have to identify how many electrons for the new compound X. That is, all of the nitrogen appears in the new compound. Now, here very clearly it has given 2 moles of N2H4. How many nitrogens are available? So here actually 4 moles. So 2 moles of N2H4 has 4 moles of nitrogen atom, right? Okay, now we have to identify per mole of nitrogen. That means here 2 moles of N2H4 has 4 moles of nitrogen. Therefore, 1 mole of nitrogen has how many electron in that way? So in that, one more point, 2 moles of nitrogen loses 16 electrons. Okay, now let me give that point for you. So number of electrons lost. So number of electrons lost per, that means 1 mole of nitrogen. So here 2 moles of N2H4 has 4 moles of nitrogen. Therefore, 1 mole of nitrogen has how many electrons? We can identify. So for that, I'll give one formula. So total moles of electrons lost. Total moles of electrons lost divided by total moles of nitrogen atom. Total moles of nitrogen atom. Right, mono atom, that is what I put circle, right? Okay, now here total moles of electrons lost, how much? Very clearly it has given 16 electrons in that 2 moles of N2H4 divided by total mole of nitrogen atom. How many nitrogen atoms are available in that total? So 2, here also 2, so 2 to 4 nitrogen atoms are available. So naturally 4 moles of nitrogen, that means 4 moles of electrons per mole of nitrogen, per mole of nitrogen atom. So that means each nitrogen atom, how many electrons is possible? 4 electrons are possible. Okay, now let us identify for the new, assuming that new compound X, how many electrons is available in that nitrogen? Let us check. Okay, now let us find out the first point. Initially, how many electrons? Now oxidation state, let us go for it. N2H4. So N2H4, hydrogen, usually hydrogen has what it is? It is a plus 1 oxidation state. No, so plus 4 oxidation state. Okay, now here 2 moles of this compound, no, that means here minus 4. So minus 4 means divided by 2. So divided by 2 means here 2. So each nitrogen atom has minus 2 oxidation state. So initial oxidation state, let me give you, because initial, and we are going to that new compound, that is final. Initial oxidation state. Initial oxidation state of nitrogen atom, it is minus 2. Here 2 moles, no, we are considering mono atom, right? Okay, now here electrons lost per nitrogen atom. Electrons lost per nitrogen atom, right? So here electrons lost per nitrogen atom, how much? Here 4, right? This one 4. So here 4, right? Now new oxidation state of nitrogen. So now we have to identify new oxidation state of nitrogen atom only they are asking. So initial nitrogen, that is initial oxidation state plus electrons lost, right? Electrons lost. Right now, you have to add that this is minus 2 and this is plus 4. So here minus 2 plus 4, how much? Altogether here plus 2. So the new compound X is there, no? So the new compound X in that nitrogen atom, how many electrons possible? Means here actually oxidation state of nitrogen atom in the new compound, in the new compound X, assuming that X mentioned in also new compound, it is oxidation state, it is plus 2 oxidation state. Okay, now how do we identify? I think you got a clear idea. See, 2 moles of nitrogen, that compound has 4 moles of nitrogen atom. Therefore, new compound, how much it is possible? So we have to identify per mole of nitrogen, then we can identify the new compound. Like the same idea, what it is, 10 apples cost this much, 1 apple, okay, so that much. So in that way only. So most of the questions will be like that only in the physical chemistry especially. And in this point, we have to think a logical way to identify this kind of sums, right? Come on. Now, which is the correct option? Option C is the correct option. Option C, this is the correct option. Hope you got the clarity. K2Cr2O7 is converted to K2Cr4. That is potassium dichromate is converted to potassium chromate. The change in the oxidation state of chromium. It is very simple. Come on, let us check. K2Cr2O7. It is converted to K2Cr4. Right, this is what they mentioned, So here K2Cr2O7 is converted to K2Cr4. Now let us find the oxidation state. It is very simple. Here actually what it is, oxygen minus 2, so that means here 14. Minus 14, right? So minus 14 means this is x. So this is plus 2. So minus 14, here minus 2, that means minus 12. So here 2x is there, no? So 2x equal to 12. So that means x equal to 12 by 2, right? 12 by 2. Here, this is different question and this is different question. Okay, now this is 6. So this is plus 6 oxidation state for each chromium atom. And the same way here, this is minus 2 oxidation, minus 2, no? So that is here minus 8. So this is minus 8 and this is plus 2. So minus 8 and plus 2 means here what it is? Minus 6. So minus 6, here only 1 chromium. So that means here when x is equal to plus 6. So plus 6 oxidation. Here also plus 6 and here also plus 6. No changes taking place. So no changes taking place means what is the answer you will be finding here? 0643. Of course, 100% it's a 0 only because there is no changes. Both are in a same oxidation state. So here also 6 and here also 6 plus 6 oxidation state. When we are going for x is equal to, so it will come this side. So automatically it is plus 6. Hope you got the clarity about both the answers. Come on, let's go to the next question. The next question, when manganese salt is fused with a mixture of KNO3 and a solid NaOH, the oxidation number of Mn changes from plus 2 to what state it may change. So here they have given the option. Come on, let us write the equation, then it will be easy for us to identify the answer. Come on. Here what it is, manganese salt, MnSO4, manganese salt combined with the KNO3 in the presence of NaOH. Right, now here you are getting MnO4 2 minus, right? Okay, come on, let us identify the oxidation state. Usually sulfate, it is minus 2 oxidation state. So that means here plus 2. Here, of course, they have given plus 2 oxidation state only. Now, what is that oxidation state? It is converted due to this reaction. Okay, now here oxygen. When we are talking oxygen, here what it is? Minus 8, right? This is minus 8 equal to 2 because it is 2 minus plus x. This is x. So here this is minus 2, no? So this is minus 2 and minus 8. So naturally, we are getting what it is, x equal to plus 6 oxidation state. So this is plus 6. So here plus 2 is converted to plus 6 oxidation state. I hope you got the clarity. So what is the answer here you will be getting? So manganese changes from plus 2 to plus 6 oxidation state. Hope you got the clarity. Okay, now let us go to the next question. So Fe2 MnO4 minus titration, HNO3 is not used because this is a formal general question in Viva. It is practical question. Why can't they use that FeSO4 and versus ferrous ammonium sulfate versus KMnO4? No? In that, why can't they use HCl or HNO3? These are all formal common question. Usually here HNO3 it's very strong oxidizing agent. So actually it leads to that inaccurate results. That is a common answer when they are asking in Viva question. But what the options here they have given, we can give according to that answer. Okay, it oxidizes Mn2 plus, it reduces MnO4 minus, it oxidizes Fe2 plus, it reduces Fe3 plus formed. Right, now let us write the equation so that it will be easy for us to understand. See here Fe2 plus MnO4 minus, this is ionic equation. Come on, write that. Let us write the equation so that it will be easy for us to identify. So here FeC2O4 plus KMnO4. This is the equation, right? And here you are getting what it is, Fe3 plus and CO2. And here what is Mn2 plus, right? So Mn2 plus. Come on, now let us identify which is oxidizes, which is reduced. Okay, now before going to identify oxidizes and reduces, let me give that what do you mean by oxidation and reduction very clearly, because a number of times if we learn also it will be easy to remember once again, right? Okay, now addition of oxygen. I hope you understand that addition of oxygen means oxidation, right? Addition of adding hydrogen, addition of oxygen. Addition of oxygen means what it is? It is oxidation. And the next one, addition of electronegative elements. So removal of hydrogen, removal of electropositive elements. So these are the points are applicable for oxidation. Just the opposite for reduction. Reduction means what it is? Addition of hydrogen, addition of electropositive elements, and the next one, removal of oxygen, removal of electronegative elements. Hope you got the clarity those 4 points. Come on, now come, let us check the oxidation state. Now here when we are going for oxidation state, here minus 8. So here minus 8 means naturally here what it is? +2. They mentioned +2 only, no? So +2 oxidation state. So here C2 it is there, no? So here C2 means here 6, no? C2 that means carbon per carbon it is +3 oxidation state, right? Okay, now the same way KMnO4 here -8 and here +1, here +1 oxidation state. So that means here what it is? +7 oxidation state. Hope you got the clarity. How do we identify instead of going for X equal to Y equal to no need? Directly we can go fatafat because only 1 minute is there to give the answer for it. So I'm explaining for you. So Fe2 plus converted to Fe3 plus. So Fe2 plus converted to Fe3 plus. 2 changes to 3. So that means it is addition of oxygen. So addition of oxygen. So this is oxidation, right? Oxidation. Okay. Now next one. Here Mn2 plus, here +7. It is converted to +2. So this is +2 oxidation. This is +3 oxidation. So this is actually what it is? Reduction. This is actually reduction. Reduce it. Okay, so here, now I just mentioned very clearly here, Fe2 plus converted to Fe3 plus. So Fe2 plus converted to Fe3 plus, this is oxidation, right? And the same way, carbon, this is carbon, actually they didn't mention, but still I would like to mention here. So here, +3, this is actually +3, right? So +3 converted to what it is? Carbon dioxide, actually what it is? Here, carbon dioxide, it is -2. That means here 4, right? So that means -4, here +4 oxidation, right? So here, carbon +4. Right. So here also oxidation takes place. Oxidation. Right. Now the next one here, that means which is reduction. Now you will come to know. So Mn that is +7. It is converted to, here these are all oxidation state. I just put it right. Okay, +7 which is converted to Mn2 plus. So this is reduction, right? So that means here increasing form, this is increasing form, this is also increasing form, this is decreasing form. So now you yourself will identify which is oxidized, which is reduced. So oxidized species is what it is? Oxidizes what it is? Iron and carbon, right? So iron and carbon, it is oxidizes. Reduced species here, which is manganese. Right. So this is reduced species. Okay. Now I hope you got the clarity, which is oxidation, which is oxidizes, which is reduced. Okay. Now here in this point, Mn actually it reduces MnO4 minus or oxidizes Mn2 plus, which will be coming, which is oxidized iron and carbon, both is oxidized, and which is reduced manganese only reduced. So it reduces MnO4 minus. Now this is oxidized. Iron, it is oxidized Fe2 plus, no, Fe3 plus, oxidizes Fe2 plus to Fe3 plus. So it means 3 plus it has to be. So it reduces, no, this also will not be the correct. Mn2 plus oxidizes. Actually, it is +7 to +2. So that means it is reduced, right? So this is B option is the correct way. See how tricky they are asking. So if you know the concept, I think you got the clarity. That is what purposely I just bring it. Once again, I wanted to repeat this dialogue for you. Addition of oxygen, it is oxidation. Addition of electronegative elements. Please listen. Addition of electronegative elements. See, this is electronegative element only now. So addition of electronegative elements and removal of hydrogen. And removal of hydrogen, is there any what it is applications is available? I'll give you later. But I would like to give this dialogue for you to remember. And removal of electropositive elements. For the oxidation, addition of oxygen, addition of electronegative elements, removal of hydrogen, removal of electropositive elements. And the same way, reduction means just to the opposite of oxidation. Addition of hydrogen, addition of electropositive elements. See, electropositive elements. And the next one, what it is? Here, removal of oxygen, removal of electronegative elements. So these are all the points are very, very important to understand that oxidation and reduction. Hope you got the clarity. Come on, let's go to the next question. I hope all these points are helpful for you to remember the main concept. Next question. Again, this question, which is repeats directly. Last question, what we mentioned in this point, this question, it is indirectly mentioned. This question, Fe2 MnO4 minus titration with HNO3 is not used because that is a general question, and they indirectly they mentioned which is reduces, which is oxidized in that way. Now, another question, you check it. Which species are oxidized and reduced in the reaction? Direct question. So in this same idea, I just bring it to you. Okay, now Fe. See, FeC2O4 plus KMnO4. It gives Fe3 plus CO2 plus Mn2 plus. Right now, the same idea I just bring here. What it is? FeC2O4, that is oxidation state, as I mentioned there only. So which is oxidized, which is reduced here. Increasing the number of oxygen, that means increasing that points from +2 to +3, +3 to +4. It is increasing form. So naturally, this is oxidation state. See, this is oxidation state. Right, and the same way, Mn, this is +7 converted to +2. So this is a decreased form. This is reduction. So I hope you got the clarity. Oxidized means increased form. Reduction means decreased form. You please remember in another point also, because usually redox reaction tricky way only they will ask. So which is the correct option? You yourself will come to know. Oxidized. iron and carbon reduced manganese, oxidized iron reduced Mn, reduced MnFe and oxidized carbon, and reduced carbon oxidized MnFe. See very clearly, oxidized means iron and carbon. See, increased form plus 3 plus 2 to plus 3 plus 3 to plus 4, and reduced form plus 7 to plus 2, so 5 it has reduced. Okay, now come on, option, which is the correct option? Option, your answer is correct. Option A is the correct option. Hope you got the clarity. How do we identify? So as I mentioned, addition of oxygen and addition of hydrogen, I hope you got the clarity of oxidation and reduction. Even increased form, decreased form also, oxidized reduces also. Now the next question what we are going to see, oxidizing agent and reducing agent, that is also very interesting. The next question, in which of the following reaction H2O2 is acting as a reducing agent? See, oxidation reduction we have gone through. Now we are going to see another one more important point, oxidizing agent to reducing agent. See, oxidizing agent, reducing agent, I just to bring it that idea for you to remember. Oxidizing agent, it accepts one or more electron and reduced itself. And reducing agent means donates one or more electron and gets oxidized itself. See, here oxidation means what it is, addition of oxygen. Reduction means what it is, addition of hydrogen. In that way we are forming. And another way, here oxidizing agent, reducing agent, in that way accepts one or more electron and donating one or more electron. This is another form of oxidation and reduction. Oxidizing agent will always be reduction, and reducing agent always will be oxidation. Right, now that is what purposely I just mentioned. Remember these points also. Right, now come on, see, in this point, in this question, one more point also it is there hiding. It is actually which is the correct form of redox reaction. So redox reaction means what it is here, redox reaction, a reduction and oxidation combined together, redox reaction. Right, now here which is the correct, which equation is the correct equation for redox reaction? That means simultaneously it has to be oxidized and reduced. Now H2O2, in which equation H2O2 is acting as a reducing agent? So reducing agent means it donates one or more electron and gets oxidized. So the involvement of H2O2 should be there in this equation. Right, now come on, let us find that which equation is the correct for it. Okay, SO2 plus H2O2. So H2O2, hydrogen peroxide plus SO2, it is giving H2SO4. 2Ki plus H2O2, it gives 2KOH plus I2. PBS plus 4H2O2, it gives PbSO4 plus 4H2O. Ag2O plus H2O2, it gives 2Ag plus H2O plus oxygen. Come on, let us check which is the correct equation. Actually, which equation is eligible for redox reaction, and which is in that which H2O2 it's acting as a reducing agent. Come on, let us check here. Option A. So option A, what it is? SO2 plus H2O2. It gives H2SO4. That is what it has mentioned. Come on. Now here, let us identify the oxidation state. So here oxidation state, what it is? Here -4. That means here +4 oxidation. So sulfur, it is actually +4 oxidation state. And the same way, this is hydrogen peroxide. No, so this is -1. Peroxide, it is -1. So that means here +1. Right. So and here H2SO4. So here we have to consider H2SO4 only. So in that H2SO4, it is actually what it is. Oxygen, definitely we have to identify in a separate way. So it is -8 and here +2. So that means here hydrogen +1. So here 2 it is there. No, so +2. So that means here +6 oxidation. So sulfur, which is converted, +4 to +6. So in that involvement of hydrogen peroxide, it is an oxidizing agent. What do you mean by oxidizing agent? Accepts one or more electron. So oxidizing agent. So this is oxidizing agent, accepts one or more electron. So H2O2 acts as an oxidizing agent in this equation. Right, now here, so oxidizing agent only. So here we cannot bring the reducing agent. Right, now that option B. So in this point, question what they are asking, in which equation H2O2 acts as a reducing agent, but here acts as an oxidizing agent only. So this cannot be the correct option. Second equation, 2Ki plus H2O2, it gives 2KOH plus I2. Right, so I2 means it's an elemental form. Oh, so easily we can identify. Okay, now the same way, this is -1. Halogen, no, so it's -1. So naturally this is +1. Right, I'm not mentioning about moles and all. So this is -1. Of course, this is +1 oxidation state. Now here OH minus, this is -1 oxidation state. This is +1 oxidation state. And elemental form, this is 0. So here iodide here -1, which is converted to 0. So that means in this point also, H2O2, it is an oxidizing agent only. So it is not acts as a reducing agent. In the question what they are asking, H2O2, it has to be reducing agent. But in this question, this is oxidizing agent. I just mentioned oxidizing agent only. I hope you got the clarity about oxidizing agent and reducing agent. Right, now, oxidizing agents means accepts one or more electron. Reducing agents means it's donating one or more electron. Right, now, come on. Next one, what it is? PBS, lead sulfide combined with H2O2. It gives PbSO4 plus 2H2O. Right. Now here in this point also, actually this is what it is. Here minus 2. So here minus 2 means here plus 2 oxidation state. Of course, this is minus 1 and this is plus 1 oxidation state. Now in the sulfur, here minus 8. So here minus 8 means here plus 2 sulfur will be what it is? Plus 6 oxidation state. So here plus 2, which is converted to plus 6 oxidation. And the same way, sorry, sulfur, no, here sulfur minus 2, which is converted to plus 6 oxidation state. And the same way here PBS which is converted here also plus 2, here also plus 2 oxidation state. So in this point, H2O2, so here also this is acts as an oxidizing agent only. This is not reducing agent. So H2O2 which acts as an oxidizing agent only. Right, now the last equation, let us check. Ag2O, option D, it is Ag2O, right? Ag2O plus 4 H2O2, hydrogen peroxide. Here we are getting what it is, 2AgO elemental form and H2O plus O2. Right, now come on, let us check the correct what it is oxidation state here. Here minus 2. So that means here what it is, plus 1 actually. Here plus 2. So this is two things. No. So it is plus 1 oxidation state. Of course, this is minus 1 and here plus 1 oxidation state. So this is elemental form. So this is plus 1 to 0. Right. Okay. Now next one here. Here what it is, minus 2. So here minus 2 means here plus 1. It is actually 2 is there. No, so this is plus 2 oxidation state. And of course, this is elemental form. Now come on, let us check. Now silver plus 1, which is converted to 0, elemental form, right? Plus 1, which is converted to 0. And the same way oxygen minus 2. Here actually what it is, here also minus 2. So now here you see here, this is also minus 2 and this is also minus 2. One more oxygen it is there. Now you see here actually what it is, O2, it is minus 1. So minus 1, which is converted to 0 form. So that means both the side what it is, oxidation and reduction takes place. That means H2O2 involvement it is there. So O2 which is converted to elemental form of oxygen O2 here. And none of the other thing is it possible to get such kind of equation. See, H2O2 it is minus 1, which is converted to 0. And the same way Ag2 it is converted to 0. So that means here in this point, this acts as a reducing agent. So which is acting as a reducing agent here? H2O2, it is a reducing agent. Reducing agent means what it is? One or more electron which donates one or more electron. So that means minus 1, which is converted to 0. So definitely it is donates one or more electron, right? That means it is what it is. Reducing agent means which is oxidized. I hope you got the clarity. Oxidized, reduced. I hope you know the difference between these two points. Okay, now which is the correct equation? H2O2 is acting as a reducing agent means option D is the correct option. Ag2O plus H2O2, it gives 2Ag plus H2O plus O2. So this is acting as a reducing agent. Hope you got the clarity. Oxidation reduction also you know the difference. And oxidizing agent to reducing agent, how do we identify? I hope you got the clarity. Come on, let's go to the next question. The next question, following reaction describes the resting of iron 4Fe plus 3O2. It gives 4Fe3 plus 6 O2 minus. Here in this statement, which is incorrect, they are asking which one of the following statement is incorrect. So this is an example of redox reaction. Metallic iron is reduced to Fe3 plus. Fe3 plus is an oxidizing agent. Metallic iron is the reducing agent. See, this is very simple. Like how do we identify oxidation reduction and how do we identify oxidizing agent and reducing agent? And the same way, another point, loss of electron, gain of electron. This is another one more concept. See, these are all concept based questions and it will be easy. And if you are thorough in that concept, it will be easy for you to identify the correct option. Again, I would like to bring it to your idea. So oxidizing agent means it's accepting one or more electron and it is reduced. So reduction means it is gain of electron. So oxidizing agent will be reduction part. So oxidizing agent is involving for reduction and it is gain of electron. And the same way, reducing agent means it donates. Donates means what it is? It's losing, right? So it is donates one or more electrons and gets oxidized. So donates one or more electron means it is oxidation. So that is loss of electron. Okay, so loss of electron. Yeah, come on. Now let us identify in this point. So the first point, what it has mentioned, this is an example of oxidation. Reduction. So redox reaction. Of course, 100% this is correct. Why they are asking incorrect option. So why this is correct? Actually, this is a best example generally for evergreen question. Oxidation reduction. Simple way for us to easy to identify eye to eye contact in that iron resting. It is redox reaction example. Why it is oxidation reduction, both it is taking place. So Fe, it is a 0 elemental form oxidation state, whereas here 3 plus. So that means what it is here actually it is what it is, loss of electron. So here 0 to 3 plus. So that means here oxidation means a loss of electron. Fe which is converted to Fe3 plus, right, and electron right? How many electron? It will be 2 electron, right? So that means it is loss of electron. So loss of electron means it is oxidation. And the same way here O2, this is also 0 oxidation state, but here -2. So that means here O2, which is converted to O2 minus. So that means it is gain of electron. So gain of electron means what it is? It is reduction. So Fe converted to Fe3 plus, it is oxidation form, and O2 is converted to O2 minus, it is reduction. So in this another point, oxidation means it's a loss of electron. So from here it is losing electron, and from here it is gaining electron. So losing electron and gaining electron, it is based on reduction. Reduction and oxidation and reduction, it takes place. Oxidation means what it is? Loss of electron. Reduction means what it is? A gain of electron. Like, okay, so this is completely 100% redox reaction. Reduction, oxidation, both, it is simultaneously, it is taking place. So this is what it is, correct option. Now they are asking incorrect option only, right? Okay, now metallic ion is reduced to plus 3, that is what it is, Fe3 plus. So metallic ion, this is metallic ion, which is converted, reduced to plus 3. How is it reduced? Actually, it is increased form. No, 0 to plus 3, which is an increased form. So increased form means what it is? Oxidation process only. So it is actually loss of electron also, we can say. Increased form, it is 0 to plus 3, it is increased form also oxidation. Another one more question I just mentioned. So that means oxidation only, increased form. Reduced, it will be what it is, decreased form. In that, reduced to Fe3 plus. No, this will not be the correct, and this is incorrect option. So B, it is an incorrect option. Come on, let us check another two. Fe3 plus is an oxidizing agent. So oxidizing agent means what it is? Accepts one or more electron and it is reduced. So Fe3 plus is an oxidizing agent. So Fe3 plus is an oxidizing agent, accepts one or more electron from another substance. So that means it causes oxidation. Fe, which is converted to Fe3 plus, which is causes oxidation in another substance, and Fe3 plus accepts electron. This is actually accepts electron and indicating this is reduction. It is a gain of electron, right? Okay, now the last point, what it is? Metallic ion. So metallic ion, it is a reducing agent. So metallic ion, what it is? Here it is a loss of electron and gets oxidized. So here loss of electron only, no, and gets oxidized. So from here 0 form to, from here the electrons are losing. So naturally this is what it is. Loss of electron means what is? Oxidation. Loss of electron, which is oxidation. So metallic ion is oxidized. It acts as a reducing agent. Donates, right? So donates means what it is? Loss of electron, right? Okay, loss of electron, and it just donates one or more electron and gets oxidized. I hope you got the clear idea about these points. Now, which is the incorrect option? Metallic ion is reduced, which is incorrect. Reduced to Fe3 plus, which is incorrect option. I hope you got the clarity about oxidation, reduction, oxidizing agent, reducing agent, and loss of electron, gain of electron. I hope you got the clarity. Come on, let's go to the next question. Right, the reaction does not represents auto redox or disproportionation reaction. Right, now redox reaction means what it is? Simultaneously oxidation, reduction together. So one it has to be oxidized, the other one it has to be reduced. That is auto oxidation, like last question we have seen. Now here disproportionation reaction, what do you mean? That this also, that here the reaction, disproportion reaction is actually same element both oxidized and reduced. That is called a disproportionation reaction. So oxidized means what it is? Loss of electron, and reduced is what it is? Gain of electron. Oxidation, reduction, only oxidized, reduced, in that form it has mentioned. Okay, now that means they have given that equation. So which equation is not eligible for redox reaction? Indirectly they are asking. See how easiest way, how they are tricky way they are asking. Now come on, it's very easy. Come on, let's check it. Cl2 plus OH minus. Here Cl minus, ClO3 minus, H2O. So that means here Cl2 plus OH minus, it gives Cl minus plus ClO3 minus plus H2O. So in this, actually this is 0 oxidation state, it is 0, and this is minus, of course. So this is actually -1. This is -1 oxidation state, and of course this is actually what it is? -6 equal to -1. So that means here what it is? +5 oxidation state, and here, so here plus, here actually what it is? 0, which is converted to minus, and again ClO3 minus, which is plus. So that means here oxidation and reduction, 0 which is converted to -1 and +5. So oxidation, reduction, both it has taken simultaneously. So option A, it's both auto redox only. So but here does not only they are asking. Now come on, let us check which is the incorrect option. 2H2 2H2O2, it gives H2O plus O2. So hydrogen peroxide, you know very well, it is a -1. So here -1, here +1. Oxidation state, you know, in that point only, no previous question. So here what it is? Minus, here minus 2, here plus 2. So here plus 1 which is converted to plus 2, here minus 1 which is converted to minus 2. So that means plus 1, here actually plus 2, and here minus 1, here minus 2. So that means here elemental form 0. So here minus 1 which is converted to 0. So that means oxidation reduction both it has taken simultaneously. So naturally this is also auto redox or disproportionation reaction. Next one, here what it is, Cu, C option, Cu plus, that is 2Cu plus, it gives Cu2 plus Cu. So this is elemental form 0, and here this is plus 1, it has mentioned now, so this is plus 1, and here 2 plus. So this is both oxidation and reduction. Plus 1 which is converted to plus 2, plus 1 which is converted to 0. So both oxidation reduction, both it has taken place. So this is also auto reduction form. And the last one here very clearly it has mentioned. So NH4 option D, here NH4 twice, see equation we just go NH4 twice Cr2O7, NH4 twice Cr2O7, NH4 twice Cr2O7, it gives N2 plus Cr2O3 plus 4H2O. H2O. Come on, let us identify the oxidation state so that we can identify very easily whether it is auto redox reaction or not. So usually ammonium, it is a plus 1 oxidation state. Right now here that means this is plus 1 oxidation state. So plus 1 oxidation state here means equal to plus 1, right? So this is plus 4. Hydrogen, it is plus 1, so into 4 it is plus 4 equal to plus 1. So this is X, no? So naturally this is minus 3 oxidation, right? This is if you are bringing this side, automatically you will get plus 3. So this means this is minus 3. So minus 3, and this is this nitrogen, it's 0 elemental form oxidation state. And the same way here Cr2O7. So usually this is minus 14, right? So minus 14 means when it is coming this side, actually this is twice, no? So that means here what it is, plus 6. Plus 6 means what it is, plus 6 means plus 3 oxidation state, right? So chromium, it's a plus 3, ammonium dichromate, it's a plus 3. And the same way here minus 6, here minus 6 means here plus 6. So here also plus 3 oxidation state. So here also plus 3 and here also plus 3. Chromium, it is plus 3, and this side chromium also it's plus 3. So there is no oxidation reduction, 0. And the same way this is what it is, minus 3 which is converted, this nitrogen ammonium which is converted 0. So that means minus 3 which is converted to 0 increased form, and a decreased form where it is actually they did not provide that decreased form, increased form. Where there is a increased form, decreased form, only we can identify oxidation reduction, then only we can go, it will be eligible for redox reaction. But in this point, special case, there is no reduction form. Here what it is, minus 3 to 0 increased form, oxidation form only, there is no reduction form. See, this is actually intramolecular redox reaction. So this is a different element actually, nitrogen and chromium and oxygen, 3 are there. So in this, nitrogen and chromium goes for, both are going for what it is, nitrogen also it's going for oxidation. Chromium actually there is no changes, plus 3 and plus 3 only it is there now. So this is also going for oxidation process. So there is no reduction point. That is what I just mentioned. Oxidation increased form it is there, but there is no reduction form. So hope you got the clarity of this now, which is that does not auto redox reaction. That means disproportion. So NH4 twice Cr2O7. So please remember NH4 means it is plus 1. So in that way you can bring. Okay, come on. Which is the correct option among this? So this is the correct option. Yes, this is the correct option. Now other than that, these are all correct what it is equation for redox reaction. Hope you got the clarity. Come on, let's go to the next question. Redox reaction. H2SO4 reacts with NaOH. In atmosphere, O3 is formed from O2 by lightning. Evaporation of H2O. Oxides of nitrogen are formed from nitrogen and oxygen by lightning. See, you will get the very clear idea about redox reaction, which is the correct option. See, again, we are giving that more ideas about redox reaction. So that means you have to be thorough the redox reaction concept way. Right now, option A. So in that option A, what they mentioned, option A, here H2SO4 plus NaOH. Right, you are getting, see, this is base and acid, so you will get salt and water. It is a neutralization reaction. Neutralization reaction. So naturally oxidation state will be same, right? So neutralization reaction, oxidation state will be same. So this will not be the correct option, right? Now next one, atmosphere of O3 is formed from O2. See, O2 which is converted to O3. So O2, this is actually 3O2 and 2O3. So oxygen which is converted to ozone. This is an elemental form. This is not like oxidation reduction. So this is also same trophic transformation. This is okay. This is also that what it is, no redox reaction. Redox reaction. So this is redox. This also no redox reaction. Right. Now third option, what it is, evaporation of water. This is actually, so what it is, a liquid state converted to gaseous state. This is a state form. So no, this is also not a redox reaction. Yes, evaporation of water. How is it possible? Liquid form converted to gaseous form will not be there. Redox reaction, redox will not be there. Okay, this is also not redox reaction. And the last one, oxides of nitrogen are formed from nitrogen and oxygen by lightning. How nitrogen and oxygen by lightning? So here, come on, let us check very clearly. Nitrogen um, and oxygen gives 2NO. So oxides of nitrogen formed from nitrogen and oxygen by lightning. So this is also elemental form. This is also elemental form, oxidation state 0. This is also oxidation state 0. When it comes over here, this is -2 and this is +2. Yes, of course. So that means nitrogen, which is converted to +2 oxidation state, O2, which is converted to -2 oxidation state. So 0 converted to +2, 0 converted to -2. So that means simultaneously both are taking place at as oxidation as well as reduction. So transfer of electrons. So redox reaction involves what it is mainly transfer of electrons, loss of electrons, gain of electrons. That is very, very important. So transfer of electrons between atoms resulting in change in oxidation state. So definitely, which is the correct option? Which of the following is redox reaction? Of course, 100% our eyes will go and identify option D. Why? Oxide, NO, oxides of nitrogen are formed from nitrogen and oxygen by lightning. 100% this is what it is, redox reaction. See, basically you got that very good clarity about oxidation and reduction, oxidizing agent and reducing agent, loss of electron and gain of electron. So transfer of electrons, transfer of atoms, what it is, transfer of electrons between atoms resulting change in oxidation state. I hope you got the very clear idea about redox reaction. Come on, let us check and some more sums. Next question, which of the following is a redox reaction? See, there are so many examples, mixes to identify and understand very clearly about the redox reaction. Come on. Here, option A, 2NaAgCN coordination compound plus Zn. It gives Na2Zn Cn 4 times plus Ag. Yes, I just bring it here. So usually here oxidation state, it's very easy to identify. So this is +1 oxidation state, and here of course this also +1 oxidation state of silver. Usually cyanide, it is -1 oxidation state. Only we are talking about my oxidation state only here. I'm not bringing that oxidation number here, right? So this is elemental state, so this is oxidation state is 0. So here yeah, again here what it is, Zn here it is +1, right? Here +2 oxidation state. Of course this is -1, right? So that means here Ag, it is elemental form, 0 oxidation state. Now here in this Ag, which is converted +1 to 0, that means here decreases, +1 to 0, it is decreases. And the same way here what it is, 0 to, here what it is, 0 to what it is, +2. So 0 to +2, which is increases. So this is increases and this is decreases. So increases what it is, 0 to +2, and decreases what it is, +1 to 0. So naturally redox reaction is what it is, oxidation and reduction. Oxidation, it is an increased form, reduction, it is a decreased form. Okay, so in that way here +1 to 0, 0 to +2. So naturally it is increased or decreased form. So 100% this is redox reaction. Redox reaction. Right. Now the second one, what it is, the second one, Ba2 plus H2SO4, it gives BaSO4. Now let us check whether it is what it is, redox reaction. So here Ba2SO4, so BaSO4 H2O2, this is actually double displacement reaction. See, BaSO4, this is which is changed over here and this which is changed over here. So this is actually double displacement reaction. So double displacement displacement double displacement reaction will not be a redox reaction. So this is non-redox reaction. Redox reaction. Okay, so now third one, what it is, third one, what it is, N2O5 plus H2O, it gives 2NO3. So here what it is remains the same. See here, this is what it is, -10, right? So here what it is, +5. So +5 is changing into +10 here. So +5, right? So +5 means here what it is, nitrogen -6 here. +1 here, +5 nitrogen, which is same here, +5 here also +5. And the same way here what it is, oxygen here -1 here +1. So that means here also +1, here also +1, right? Oxygen. So +1 and +1, here also +5 and +5. So there is no oxidation reduction. So this is non-redox reaction. Non-redox reaction. Right. So oxidation reduction has to be simultaneously. So that is what. Now next one here, AgNO3 plus Ki, it gives AgI plus KNO3. See, this is also remains the same. So this is also remains the same. Here what it is, -1, here +1. Right now here what is it? What is it here also? This is +1 oxidation state. NO3, it is not that big. What it is? There is no bracket. Right now here what it is, -6. Here +1. So here also +5 oxidation state. And this this is also -I. So this is also -1 only. So here also +1. This is also plus 1, this is also plus 1, no changes. And here minus 6, here minus, here plus 1, and here plus 5. So there is no changes here. Nitrogen in the form, here nitrogen also the same. So remains the same. So this is not at all redox reaction. Non-redox reaction. Non-redox reaction. So I hope you got the clarity. What is redox reaction? What is non-redox reaction? That means which is not eligible for being as a redox reaction. Redox reaction means what it is: decreasing form, increasing form in that oxygen or electron in that way, right? Okay, so which is the correct option? Only first option only is the correct. Okay, so first option is the correct, which is the following redox reaction. Option A, it follows. These are all not redox reaction. Hope you got the clarity, and a number of questions will help you to identify exactly. Right, come on, let's go to the next question. O4 2 minus plus H plus, it gives Mn2 plus CO2 plus H2O. The correct coefficients of the reactants for the balanced reactions are respectively MnO4 minus, C2O4 2 minus, and H plus. So what is the correct balanced equation? That we have to check it. Now, according to that balanced equation, we have to identify number of electrons lost or number of electrons gained. In that way, here oxidation state, here actually oxygen minus 2, no? So here minus 8. So minus 8 equal to minus 1. So that means this is plus 7, right? So this is plus 7 oxidation converted to plus 2. So how many electrons exchange in that? Here 5 electrons exchange. So 5 electrons exchange, right? Now in this point, here oxalate ion, here actually what it is, minus 2, that is C2O4 2 minus. So that means minus 8 equal to minus 2. So that means here what it is, minus 6, that C2 is there, no? So that is plus 3. So plus 3 per carbon, right? So plus 3, which is converted to here oxygen carbon, right? So this is minus 4, this is plus 4, right? So plus 3, which is converted to plus 4. How many electrons exchange here? 1 into 2. 2 minus, no, so that is what 2. So here 2 electrons exchange, right? So 2 electrons, right? Now we have to balance. So how many electrons are giving? That many electrons which is taking place over here. So that means here we have to put 5. And the same way here, how many electrons? It is what it is, gains here 2. So that means here 2. So now we have to balance that oxygen and hydrogen. That is what water molecules, right? So how many oxygens are there? 4 oxygens, but how many moles? Here 2. So 2 fours are 8. How many oxygens are there? That many water molecules. Please remember, how many oxygens are there? That many water molecules. So that means 8 water molecules. How many hydrogens? See now, how many hydrogens are there? That many H plus ion. That means here 16. Got it? So how many oxygens are there? That many water molecules. How many hydrogens are here? That many H plus ion. So that means what is the exact coefficient? So 2 MnO4 minus plus 5 C2O4 2 minus plus 16 H plus ion. So that means what is the coefficient? 2, 5, 16. So which is the correct option? 2, 5, 16. Option A is the correct option. See, this is redox reaction. How many electrons are losing? How many electrons are gaining? In that way, we have to interchange, multiply with that. So that is the way easily we can identify here. 1 electron change, no? So 1 electron, in that how many electrons? So here 1 into 2, so 2 electrons. In this way, here 7 electrons, here minus 1 only, no? So here plus 2, so that means 5 electrons only. So here 5 oxalate ions is gaining, this is losing. So in this way, here oxygen is gaining, that it has to be taken over there. So oxidation reduction only, redox reaction. Hope you got the clarity about this question. Come on, let's go to the next question. Next question. In a chemical reaction, K2Cr2O7 plus XH2SO4 plus YSO2, it gives K2SO4 plus Cr2SO4 thrice plus ZH2O. The value of X, Y, and Z are respectively K2Cr2O7 plus XH2SO4 plus YSO2, it gives K2SO4 plus Cr2SO4 thrice plus ZH2O. See, here, let us find out the oxidation state so that it will be easy for us to identify. So this is minus 14 oxygen, it is minus 2, right? So automatically this is minus 14. So minus 14 and potassium plus 1. So here 2 it is there, so here plus 2. And naturally you will get here 12 by 2. So this is 2x, no, 12 by 2. So this is plus 6 oxidation state. So plus 6 oxidation state converted to plus 3. How do we get plus 3 here? Sulfate, actually what it is? Minus 2. Minus 2 into 3, minus 6, right? So minus 6, this is 2x, no? So 6 divided by 2, so that is plus 3. So plus 6, which is converted to plus 3 oxidation state. So this is actually what it is. Here reduction, plus 6 converted to plus 3, it is reduction, right? Now oxidation, SO2, sulfur ion, we have to check it. So this is actually what it is, minus 4. And here actually plus 4 oxidation state, right? Plus 4 oxidation state. So plus 4 oxidation state, which is converted to this sulfate ion, no? So in this point here, actually, here what it is, minus 8. So here minus, here plus 2. So naturally you will get plus 6. So plus 4, which is converted to plus 6. So this is oxidation, right? So this is oxidation, this is reduction. Okay, now let us write that equation clearly, oxidation and reduction. check the reduction and oxidation equation, right? So reduction, this is actually reduction and oxidation, right? Oxidation. All right, so reduction equation, what it is? Cr2O7 2 minus. And how many electrons change? It is 6 electrons, right? So here plus 6, which is converted to plus 3. So that is 6 electrons change. So you are getting what it is? 2Cr3 plus. So plus 6, which is converted to plus 3, right? So the same way, SO2, right? SO2, what it is? Here in this point, SO2, which is converted SO4 2 minus, right? So SO4 2 minus. So how many electrons exchange here? Here 2 electrons exchange. 2 electrons, right? So in this point here plus 2, and here what it is? Plus 6. How many electrons exchange? 2 electrons exchange. Here 6 electrons. So 6, which is converted to 3. That means each, what it is? Chromium 3. So 3 plus 3, 6 electrons. In that way, see, 2 chromium combined together, it is 6 electrons. So that is per chromium, it is 3, another chromium, it is 3. So 3 plus 3, 6. Right now, multiply, this is multiply with 3. So you will be getting what it is in this K2Cr2O7 here. Cr2O7 2 minus plus 3SO2. Here what you will write? 3SO2. You will be getting what it is? 3SO4 minus plus 2Cr3 plus. So natural equation, how to write it? Here K2Cr2O7. So K2Cr2O7, K2Cr2O7, here one hydrogen only. So the hydrogen point will be 1, but sulfur point will be 3, right? And hydrogen here also, water molecules hydrogen point will be 1. So X equal to 1, Y equal to 3, and Z equal to 1. So 1, 3, 1. So option A is the correct. So while balancing that ionic equation only, easily we can identify losing electrons and gaining electrons added to that, right? I hope you got the clarity about all these questions. Okay, come on, let us go to the next question in our next video. And thank you for watching.